Alright, so we're looking at problem 4 from the first exam. So we're given a function g of x equals f of x squared times f prime of x, and we're told that f of x is a function which is twice differentiable, and we're given some values. So we're told that f of 2 is equal to 2, f of 4 is negative 6, f prime of 2 is equal to 3, f prime of 4 is equal to negative 1, f double prime of 2 is also equal to negative 1, and f double prime of 4 is equal to 0. And we're asked to find g prime of 2. So the general strategy for doing this would be to find first what's the derivative of g, and then plug in x equals 2 to find the derivative at 2. So let's try to find the derivative of this function g. So we have a product of two functions, f of x and f prime of x. So if we use the product rule, then we take the derivative of the first function times the second function plus the derivative of the second function, which is just f double prime, times the first function. Now this derivative of f of x squared, since there's a function inside the f of x, we need to use the chain rule. And so the derivative of the inside function is 2x. So we get 2x times f prime of x squared. This is that derivative by the chain rule. We multiply by f prime of x, then add f double prime of x, f of x squared. So this is a formula for g prime of x. So to find g prime of 2, we just plug in 2 everywhere. So it's 2 times 2, f prime of 2 squared, which is 4, f prime of 2, plus f double prime of 2, f of 4. Now if we plug in all the information that we were given, we see this is 4, f prime of 4 was negative 1, f prime of 2 was 2, let's see, sorry, f prime of 2 was 3, plus f double prime of 2 was negative 1, and f of 4 was negative 6. So if we simplify this a little bit, we have negative 12 plus 6, or negative 6 as our final answer.